Have you ever stopped to really think about your skin? I mean, it's not just a covering. It's a masterpiece, a living, self-repairing work of art that you, yourself, began creating before you were even born. It is an absolutely incredible story of biological construction, and it all starts with just a few cells that eventually become the most complex and personal organ you will ever own.
So, here's how we're going to walk through this creation story. First, we'll look at the initial blueprint. Then, we'll watch as the first protective coat gets assembled. After that, we'll see how the living foundation is built and all the specialists are brought in. Then, it's time to install all the high-tech gadgets. And finally, we'll meet the incredible repair crew that keeps this whole thing running for a lifetime.
Okay, let's just dive right in. You know, every complex structure, whether it's a skyscraper or a symphony, it has to start with a blueprint. And for our skin, that blueprint gets laid down unbelievably early, just 3 weeks into development. This whole foundational moment, it's called gastrulation. And it sounds super technical, but really it's this incredible, almost chaotic-looking dance where all the cells start reorganizing themselves, sorting the entire embryo into 3 distinct layers. It's kind of like sorting all your Legos before you start building, right? You make one pile for the outside walls, one for the internal structure, and one for all the furniture that goes inside.
And right here, you can see that perfect division of labor. Now, for our skin story, we're going to focus on these top 2 layers. You've got the ectoderm, the outer layer, which is going to become our epidermis. That's the visible skin you see every day. And right underneath that, the mesoderm, the middle layer, is the source for our dermis, the strong, supportive foundation holding it all up.
All right, the blueprint is set. Now the first real phase of construction can begin. Building the epidermis. And this isn't just some flimsy covering, this is our body's primary shield against, well, everything in the outside world.
And what's so amazing to me is how simply it all starts. Our incredibly complex, multi-layered epidermis begins as nothing more than a single, fragile sheet of cells that's just stretched over this tiny little embryo. From that one simple layer, this whole intricate barrier is about to be built. And this construction project is on a crazy tight schedule. By 8 weeks, that single layer is already starting to build on itself, making more layers. By 15 weeks, you see the first signs of hardening happening down inside what will eventually be hair follicles. Then, around 22 to 24 weeks, the main skin surface starts forming its tough final outer layer. Now, during all of this, the developing skin is covered by this fascinating temporary layer called the periderm. A great way to think of it is like biological shrink wrap. It's protecting the delicate construction site underneath, and it even helps manage what goes in and out from the amniotic fluid. And then, once its job is done, it's just shed. Pretty cool.
This entire process is guided by an incredibly precise genetic program, which, of course, leads to the question, what happens if there's a typo in those instructions, a bug in the code?
Well, when the genes that are responsible for building that final barrier, that tough outer layer called the stratum corneum, when they're defective, the results can be just devastating. It's like trying to build a brick wall with bad mortar. It can lead to what's called a collodion baby, where the infant is born encased in a tight, shiny membrane that almost looks like plastic wrap. In the most severe cases, it causes harlequin ichthyosis, where the skin hardens into thick plates. It's a tragic, powerful reminder of just how critical every single one of those genetic instructions really is.
So let's move down to the layer just underneath all that. While the epidermis is our shield, the dermis is what gives it that strong, flexible foundation. And this is where the specialized artisans, the real craftsmen, are brought in to bring this masterpiece to life.
Now, get ready for this because this is one of biology's really elegant surprises. You'd think the dermis is all built from one uniform source, wouldn't you? But it's not. The dermis on your face and scalp actually comes from something called the neural crest, which is part of the ectoderm. But the dermis everywhere else, that comes from the mesoderm. This dual origin is exactly why some genetic syndromes can affect both your facial structure and your skin pigmentation at the same time. It's all connected.
So one of the most important specialists to arrive on site are the melanocytes. These are the cells that produce pigment. They actually start their life way back in the neural crest, and then they have to go on this incredible journey, migrating through the developing embryo along these very specific pathways to reach their final home in the epidermis. They show up around day 50 and get ready to set up shop.
It's a truly remarkable migration, but what happens if some of these cellular travelers get lost? What if they just don't make it to their final destination?
Well, when that cellular supply chain breaks down, it actually leaves a visible record on the skin. You get conditions like piebaldism, which results in these really distinct patches of skin and hair that have no pigment at all.
And these patches, you'll often see them on the central forehead or on the abdomen. They are not random. They are a literal map showing the exact points where those migrating melanocyte precursors failed to arrive during development.
Okay, so the main structure is built, and the specialists are in place. Now it is time to install all the high-tech gadgets. We're talking about the hair, the nails, and the glands that make our skin so incredibly functional.
Now, it's really important to understand that these things don't just sprout out of the epidermis on their own. Their formation depends on this constant, intricate molecular conversation, a back and forth between the epidermis on top and the dermis down below. It's this beautifully coordinated effort.
Let's just take the hair follicle. First, the dermis sends a signal up. It tells the epidermis, hey, we're going to build a hair right here. In response, the epidermis thickens up into something called a placode. This placode then starts to grow down into the dermis, forming a hair germ. And then it gets even longer, becoming a hair peg, which wraps around a little piece of the dermis that's going to become its lifelong source of food. It's just a beautiful dance of communication.
And just like any well-managed construction project, there is a very clear installation schedule. You can't just do things in any old order. Fingernails get started around 8 weeks. A couple of weeks later, the first hair follicles show up on the scalp. Then come the oil glands and the sweat glands. Everything happens in a precise, perfectly coordinated sequence.
And with that, the masterpiece is complete. But how does it last for 80, 90, even 100 years? Well, the secret is that it comes with a built-in maintenance plan, powered by a remarkable forever repair crew.
And this crew is made of skin stem cells. Now, these cells are biological superstars. They basically have 2 superpowers. First, they can create daughter cells that become all the specialized cells our skin needs. And second, they can make perfect copies of themselves, which means the repair crew never ever runs out of workers.
So, just how effective are they? Take a look at this number. It takes your epidermal stem cells only about 40 to 56 days to completely renew the entire outer layer of your skin. Think about that for a second. The skin you have right now is not the same skin you had just 2 months ago. It's a constant, quiet, and absolutely incredible renewal process.
And you've really got 2 main teams on the job. There are the epidermal stem cells, located down in the bottom layer of the epidermis, and they are constantly replacing the cells on the surface. And then you have the hair follicle stem cells, which are kind of tucked away in this safe little spot called the bulge. Their main job is to regenerate the hair follicle with each new growth cycle, but they're also a critical backup crew ready to jump in and help heal the surface after an injury.
So from a simple 3-layer blueprint to a complex multifunctional organ, and finally to a system that maintains and rebuilds itself nonstop for your entire life. It's a process that began long before you took your first breath, and it's happening right now, this very moment. What does that tell you about the incredible power that's contained within a single, elegant blueprint?